I'll start off by talking about teleportation, since two-way time travel ties into a lot of the same concepts that I'll be discussing with teleportation. Also, bear in mind, I'm not actually going to go into how time travel or teleportation could actually be done. I'm just talking about some of the bigger, more conceptual problems that they could face. The thing is, at a chemical level, in the context of daily life at least, there isn't really any such thing as an object. We tend to think of objects, people, and so on as physically distinct things, which they are to us, but if you look at them at a low enough level, they aren't. Everything is just a soupy mess of gases, liquids, and solids. If a computer was capable of seeing every individual atom in a photograph, for example, it wouldn't see that in the photograph there's a person, a chair, a glass of water, a balloon, and air throughout it all. It would just see atoms, different types of atoms moving around constantly. What does this have to do with teleportation, though? Well, it's not just as simple as saying, oh, hey, teleport this person. Everything is connected in a way. Do you take the air surrounding him? Do you take his clothes? If you take the air surrounding him, do you take the air in his lungs as well? Let's assume his mouth is open. Is the air in his lungs a part of him, or is it a part of his surroundings? What about the oxygen in his bloodstream? That came from the surrounding air, so does that count? His bloodstream is open to the surroundings at a molecular level in some ways, of course, since the oxygen got in there in the first place. So, what counts as the guy you're teleporting, and what counts as his surroundings? A possible solution would be to have a box or something that teleports everything inside the box. However, we're not quite out of the woods yet. What about the destination? By an extension of the Pauli exclusion principle, two objects of mass cannot occupy the same space at the same time. Will the teleportation just push out all the mass within the area that you're teleporting to? A solution similar to the first would be that the destination would also be a box, and both of them would be perfect vacuums so that you were the only thing of mass within the teleportation box. On to time travel. Time travel causes much of the same problems as with teleportation, in addition to several more. I won't be getting into the grandfather paradox or anything like that. I'll be talking about the actual physical issues of getting there. See, with teleportation, it would probably just be a matter of teleporting somewhere else on Earth. Somewhere else on Earth that someone could have set up one of the teleportation boxes in advance. But with time travel, how would we get the first box there? After that, for any specific location, it theoretically wouldn't be as much of an issue, as you would already have someone in the past that could, hopefully, build more of the teleportation boxes. But how to get the actual box there to begin with? You would, ironically, need time travel to get the box there to be able to time travel. It doesn't exactly work. But let's disregard that for a moment. Let's assume that somehow we got a time teleportation box somewhere. Let's assume that somehow we were able to secure a connection between the one in the present and the one in the past. How will we enter in what time we want to go to? There isn't really a thing called time as we think of it. Seconds, minutes, hours, days, and years aren't real. The concept of time is real. There is, obviously, a one-way, without the use of time machines at least, continual, although not necessarily constant, stream of progression. We call this time. We measure in seconds and so on, of course, and seem to think that the universe has just decided to play by our rules. We act as though light years are a real thing, but they're just a convention we've created to quantify and measure distance in space. Years are the same way. They have meaning in context of our solar system, obviously, since they're the time it takes for the Earth to make one rotation around the Sun. But in the context of the universe, not really. it's not as simple as the solution for that problem in teleportation, which I didn't really mention earlier. How would we judge distances that you want to teleport? Well, it wouldn't really be necessary to worry about, since we're only going from box to box, each box being secured in one place and connected to each other box. The concept of distance doesn't really come into the equation. Even if it did, though, it wouldn't be too hard to work around. Since in the example I was working with, all of the teleportation was taking place on Earth, the teleportation system could measure distance out in a predetermined manner. Distances on Earth are microscopic compared to those of the universe. Things would get a bit messier if the distances were on the scale of light years. But at least with teleportation, it's simply through physical space taking place in the current moment, which can be physically measured. When it comes to time travel, though, there isn't a way of doing that. If there was some machine that was set up at the beginning of time that continually monitored and recorded the entire universe and acted as a sort of time beacon, messaging out the current time in whatever format we needed, it wouldn't be as much of a problem. But we don't have that. And to have that, we need a time machine to get there and set it up. Same problem as before. The basic point for both topics, though, is that the conventions that humanity has created to measure the 4 dimensions are only conceptual. They only exist in our minds. And that's a major problem when it comes to time travel and teleportation. But those were just my thoughts on it.